Today we're going to be using the cylindrical shells method to find the volume of the region bounded by two curves after we rotate it over the x-axis. And the curves that we're going to use are x equals 1 plus y minus 2 squared and x equals 2. Now when you're using these formulas, when you're doing this type of problem, it's important to know the formulas. When you're using with respect to x, the formula is the integral 2 pi x times height. And when you're doing it with respect to y, the formula is integral 2 pi y height. And so to find our height, we're going to subtract 1 plus y minus 2 squared from 2. And I did that here. And we get negative y squared plus 4y minus 3. That's our height. But now we're going to have to find our limits of integration. And to do that, we're going to have to factor our height. And after we do that, we'll find that y equals 3 and y equals 1. So y equals 3 is our upper limit and y equals 1 is our lower limit. And now we plug this all into the formula, and we can bring the 2 pi out because 2 pi is a constant. And so our formula is 2 pi times integral from 1 to 3 y times negative y squared plus 4y minus 3, all with respect to y. And to do this, we're going to multiply the y into our expression, because that'll make it easier when we're taking the antiderivative. So we'll end up with negative y cubed plus 4y squared minus 3y. And taking the antiderivative of that, we'll just use the reverse power rule, and we'll end up with 2 pi times negative 1/4 y to the 4th power plus 4/3 y cubed minus 3/2 y squared. And now from here on out, we just treat this like a regular integration problem, and we plug in our upper limit 3 and our lower limit 1, and we just subtract that out. And so simplified, it looks like this: 2 pi times negative 81/4 plus 36 minus 27/2 minus negative 1/4 plus 4/3 minus 3/2. And after doing a little bit of tedious algebra, we'll find that 16 over 3 pi is our answer.